Welcome Trio. We're back with another video on finding trig functions. Given one function and a quadrant, we can find the remaining trig functions. So let's get started. We have given sine theta equals negative 5/13 and theta is between 3 pi over 2 and 2 pi. So let's make a triangle. We have pi over 2, pi, 3 pi over 2, and 2 pi. So because we're between these two, we know we're in quadrant 4. Okay, so now sine theta equals negative 5 over 13. Sine is negative in quadrant 4, so we're good there. Sine is opposite over hypotenuse, so that means we have here negative 5 and here 13. Remember, hypotenuse is always positive, and it looks like we're looking for b. So we can use the Pythagorean theorem, and let's do that right now. A squared plus b squared equals c squared, or b squared equals c squared minus a squared, or b equals the square root of c squared minus a squared. Now that we have our formula to use, we can just plug in the numbers. B equals the square root 13 squared minus negative 5 squared. B equals square root 169 minus 25. B equals square root 144, which is nice. We can take the square root of that. B equals 12. Now that we know B equals 12, we can label it on our triangle. B equals 12. So we know that. Now we can find our remaining trig functions. So sine theta is given as negative 5/13. Cosine theta will be equal to, cosine is adjacent over hypotenuse, so that will be 12/13. Tangent of theta is equal to opposite over adjacent, so that's negative 5 over 12. Now that we have these three, we can find the remaining three by saying the one that corresponds to tangent is cotangent. So cotangent theta would be equal to negative 12/5. Opposite, well, the one that corresponds to cosine is going to be secant. Secant of theta is going to be 13/12. And the one that corresponds to sine is cosecant. And that will be negative 13/5. We are done. Go Trio.